Hello all. In this session we will discuss topic 2 of unit 4, which is mining sequence patterns in transactional database. So we will discuss the basic definitions for sequence database, transactional database. We will discuss different scalable methods for mining sequence patterns, for mining sequential patterns, which is GSP, SPADE, prefix span, constraint based mining of sequential pattern, periodicity analysis of time sequence data and applications. First, let us discuss the basic definitions for sequence database and transactional database. So sequence database consists of sequence of ordered elements or events recorded with or without a clear concept of time. That is, sequence database consists of sequence of ordered elements or events with that may vary or may not vary with respect to time. Typical examples include customer shopping sequence, web clickstreams, biological sequence, sequences of events in science and engineering. Next, transactional database. Transactional database stores data in the form of individual transaction, each with a set of items or events, and is commonly used for analyzing purchasing behaviors. Next, time series database is also a sequence database. However, a sequence database, there is a small difference between time series database and sequence database. A sequence database is any database that consists of sequence of ordered events with or without concrete notion of time. For example, web page traversal sequence and customer shopping transaction sequence are sequence data, but they may not be a time series data. So let us consider an example of customer shopping transaction wherein a customer visits a site, views a product, adds it to cart, goes to checkout and purchases the product. This is a sequence of ordered event and this is a sequence database. This comes under sequence database. Next, sequential pattern mining. What is sequential pattern mining? Sequential pattern mining is the mining of frequently occurring ordered events. Frequently occurring ordered events. For example, customer who buys a Canon digital camera is likely to buy a HP color printer within a month. So this is useful in retail where the sequential patterns are useful for shelf placements and promotions. For example, products used together are kept in one place. For example, bread, jam, butter, they may be used together. That's why they are kept nearby. Other areas in which sequential patterns can be applied includes web access pattern analysis, web prediction, production process and network intrusion detection. Next, let us discuss the techniques for mining sequential patterns. So first one is scalable method, second one is constraint based mining. Scalable methods are techniques used to efficiently mine sequential patterns from large data sets. Next, constraint based mining refers to process of mining sequential patterns while applying user defined constraints to focus on specific patterns. So let us discuss this first one by one. First, scalable method for mining sequence pattern. These are methods designed to work efficiently with large data set. They reduce time and memory needed to find a pattern by organizing the data smartly and limiting unnecessary calculations. Where it's used in businesses like retail and e-commerce to analyze customer buying habits or web browsing behavior. The different techniques are GSP, SPADE and prefix span. So first one, GSP. GSP is generalized sequential pattern. It is an extension of a priori algorithm. GSP generates candidates iteratively and removes infrequent patterns based on minimum support threshold. So let us discuss the process. GSP generates candidates. For example, if we are considering the example of milk, bread, butter, then these are the different candidates. So first GSP generates candidate sequence like milk, butter, bread, butter. We'll be discussing this example. So then it checks how often these candidates appear in the data set. If the candidates appear more than minimum threshold, more than minimum support threshold, it is retained as frequent sequential pattern. The algorithm tests and validates these candidates until it identifies frequent subsequents like milk, butter, bread, butter. Next one is spade. Spade is sequential pattern discovery using equivalence classes. The process is in spade. Patterns are mined based on equivalence classes, that is, group of items that occur together in sequence. Spade efficiently discovers frequent patterns by applying set intersection to find common occurrence between the sequence. For example, subsequence milk, bread appear in all the four sequences. That is, we are going to take an example next. We are going to see an example in that milk bread appears in all the four subsequences, so it could be considered a frequent sequential pattern. Next, using the example is customer purchase sequence. Spade stores the dataset in vertical format. So we will be seeing this. Let us discuss the GSP and spade. Let us consider the input sequence S1 as milk, bread, butter, S2 milk, butter, bread, S3 bread, butter, milk, S4 milk, bread, butter, cheese. In the same way, let us consider the same sequence in spade, whereas it is written as T1, T2, T3, T4. T is nothing but transaction. So let us first check the one item sequence. So here milk occurs 4 times, that is in all the four sequence. Milk occurs 4 times. In the same way bread, the same way butter. Whereas on the spade side, so milk occurs in transaction IDs T1, T2, T3, T4. Bread occurs in transaction IDs T1, T2, T3, T4, and butter also occurs in the transaction ID T1, T2, T3, T4. Let us generate the two item sequence. So we have milk bread, milk butter, and next bread butter. So are milk and bread occurs in first one, second one, that is milk bread occurs in first one, second one, and also in the fourth one. So milk bread 3 times. In the same way milk butter 1, 2, 3. So it also occurs, it has a support of 3. In the same way milk butter, sorry, bread and butter. So bread and butter 1, 2, 3. So it also occurs 3 times. In the same way on spade side, that is milk bread occurs in T1, T2, T4. Milk butter occurs in T1, T2, T4, and bread butters occurs in T1, T3, and T4. and the support is 3, that is it occurs 3 times. Now let us generate 3 item sequence. So we have milk, bread, butter, milk, bread, butter, milk, bread and butter, milk, bread and butter, which occurs twice, that is support is equal to 2. So milk, bread, butter occurs 2 times. So here also milk, bread, butter occurs 2 times, that is in transaction T1 and T4. So final, these are the final frequent sequence: milk, bread, butter for one, if we take once. Next for 2 item sequence: milk, bread, milk, butter, bread, butter. For 3 item sequence: milk, bread, butter. In the same way in the other side, that is in the spade side. Next let us discuss the next topic, which is prefix span. Prefix span stands for prefix projected sequential pattern growth. Given the same purchase sequence like the before one, prefix span focuses on projecting the data set based on the frequent prefixes. For example, starting with the frequent prefix, which is milk, the algorithm projects the dataset to subsequence that start with milk. That is sequence 1 milk, bread, butter. Sequence 2 also prefix is milk, so milk, butter, bread. Sequence 4 also has a prefix, that is first it has milk, bread, butter, cheese. It recursively mines the projected subsequence, growing the pattern incrementally. These patterns discovered would include milk and bread, milk and butter, which are frequent across the sequences. Next, let us discuss the constraint based mining of sequential pattern. So, without any user defined constraints, mining can generate irrelevant patterns, reducing efficiency and usability. Constraint based mining incorporates user specified constraints to focus the search on pattern of interest, improving both efficiency and relevance of support. That is, here we try to keep a constraint in order to improve the efficiency. Suppose we are analyzing customer shopping behavior where each sequence represents a customer's purchase history. So we can use the constraints like duration constraints. We want to find the sequential pattern of the products bought by the customer only in the year 2023. So this is the constraint here, 2023. This constraint will limit the sequences being mined to only those occur during 2023, ignoring the sequence from the other years. The other constraint is monotonic duration constraint. We want to find customers who bought at least 5 items in any sequence. So here the constraint is t greater than or equal to 5. So once we find a sequence with 5 items, all the subsequences with more than 5 items are also considered valid, ensuring we capture longer patterns. So in monotonic duration constraint, we try, for example, we want to find customers who bought at least 5 items, means we will be getting more than 5 items. We will consider the subsequences with more than 5 items. Next, periodicity analysis of time sequence data. So in this we try to detect repeating patterns or periodic behavior in a time series data. Example, electricity usage shows a pattern, that is high usage at 8 a.m. daily morning, low usage at 2 p.m. Next, key features useful for detecting regular cycles in data such as seasonal trends or recurring events. Next, last one is the applications. So first one, retail and e-commerce. In this, we try to discover purchase pattern. Example, customer buying shoes often buy socks. Next is web usage mining. Analyze browsing patterns to improve the website navigation. Sequence, for example, customer goes to home page, product category, product details, add it to cart and checkout. So this is a sequence pattern. So using web usage mining, what we can do is, if a customer is trying to use, if the customers are trying to search for a particular product, then that product can be kept on home page. This will help to improve the website navigation. Next one is medical data analysis. So to study sequence of symptoms, diagnosis or treatments to identify patterns in disease progression or treatment outcomes. Next one is social media. Track users' activity and interaction to personalize content delivery and improve the ad targeting.